Okay, first of all, I like to write it in this form. The function is a root function, input as x plus 1, afterward you subtract 1. This means x changes this way, x minus 1, and y changes it this way. Right? So this plus 1, because it's plus 1, is subtract 1. This minus 1 behaves the way you see it. It brings the y down by 1. Now, the points in the original function of root of x, the ones that we used were 0, 0, 1, 1. What's the next perfect squared after 1? 4, 2, right? 4, 2, right? That's a perfect square per square root that you get 2. So they become negative 1, negative 1, 0, 0, 3, 1. Okay, so negative 1, negative 1, 0, 0, 1, 2, 3. Okay, 3 and 1. So this is my picture. You guys follow so far? Okay. Now you could find the inverse using algebra. Switch the x and y, okay? But you don't need to. See this point? Negative 1, negative 1. What happens if you switch the coordinates? It still stays at here. But what about this one? Well, it actually still stays there. 0, 0, right? This last one will switch. 3, 1 will become 1, 3. Okay, so this might be still confusing. Well, how do I use these 3 points? Okay, well, try to draw a mirror image through that line. So, if it's a mirror image, it should look like this. But this looks like it should look like a half of a parabola, half. Now, let me explain to you algebraically, because this is how I think Sally approached it, right? Let's switch the x and y. So you get x is equal to y plus 1 minus 1, x plus 1, square both sides, like that. True? Now, if you looked at this equation, you would have drawn the full parabola like this. But what you have to pay attention to is the range of this. The domain of this is x is greater than or equal to negative 1, right? What's the range? Greater than or equal to negative 1, which means for this one, x is going to be greater than or equal to negative 1. So do you see how here's negative 1? If I only want this parabola so that x is greater than or equal to negative 1, it would only be this red part. So you have to omit this part.